I am J. Tabital and today we are going to discuss on the topic of Archimedes principle and experimental verification of the Archimedes principle and some applications of this Archimedes principle. So, let us go into the subject. So, what is Archimedes principle? A body completely or partially submerged in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the body. So, when a body is partially or completely immersed in a fluid, the fluid extracts an upward force on the body which is equal to the weight of the fluid displaced by the body. So, that is shown in the image you can see. So, Archimedes principle for a cylindrical body, it is nothing but consider a cylinder of height h and area of cross section A held under the surface of a liquid. So, pressure at the top of the cylinder is P1 and bottom of the cylinder is P2. So, the force acting on the top is F1 is equal to P1 into A. Similarly, force acting on bottom is F2 P2 into A. So, these are the two forces acting. So, when we compare with the two forces, with the magnitude so, the two forces with the magnitude of Fb. So, Fb is nothing but F2 minus F1. So, F2 is P2A minus P1A. So, that can be written as P2 minus P1 into A. So, here the pressure difference of the top and the bottom can be written as P2 minus for the pressure difference of top and the bottom can be represented as H rho G. So, in the place of P2 minus P1 we are going to substitute the value that H rho G. So, we can write it as H rho G into A. Here H and A are the volume of a cylindrical body and others are rho G or the mass, it represents the mass. Therefore, upthrust is nothing but weight of the fluid displaced. So, this is the principle of Archimedes for a cylindrical body. Here is the experimental verification of Archimedes principle. It is nothing but we have to suspend a solid which does not dissolve in water and help of thin hook of spring balance. So, we have to hang that solid with the help of a hook of spring balance and dipping it in water container and to arrange the Eureka can and fill it with water up to its spout. So, you have to fill the water with the up to the spout. So, arrange a measuring cylinder which will kept below the spout of Eureka can and Immerse the solid gently into the water in Iruka can. Then the water will displaced by it gets collected in the measuring cylinder. So, water stops dipping through the spout, then note the weight of the solid, the volume of water which are collected in measuring cylinder. Therefore, the density of the water is 1000 kilogram meter power minus cube. So, here the solid weights. So, in the experimental verification, the solid weight in air is 10 N, in immersed water is 6 N. So, displacement of water is displacement of water is 400 centimeter cube. So, now we have to find the loss of weight. How we can find the loss? Loss of weight is nothing but 10 N minus 6 N, which gives 4 N, and so we have found the loss of weight, and the volume of liquid is equal to volume of the solid, that is equal to 400, the volume of liquid displaced. So, 400 centimeter cube can be written as 0.004 meter cube. So, we have found the volume and the loss of weight, and now the density of water is nothing but 1000 kilogram meter power minus 3. So, the weight of water displaced is nothing but 0.0004 into 10 power 3 kgf, which is nothing but 4 N. So, this is the weight of the water displaced in the experimental verification of Archimedes principle. So, it is found that the weight of the water displaced by the solid is equal to the difference in weight of solid in air and in water. So, the loss of weight of the solid is that verified the Archimedes principle. So, there are two conclusions. One is Archimedes principle gives us the value of buoyant force. According to the Archimedes principle, when an object is wholly or partially immersed in a liquid, it experiences a buoyant force which is equal to the weight of the liquid displaced by the object. The second conclusion is buoyant force acting on an object is equal to the weight of the liquid displaced by the object. If a body of volume V is immersed wholly, that is fully, in a fluid of density rho, then the volume of the fluid displaced by the body is also V, and the mass of the fluid displaced by the body will be rho into V. So, the buoyant force of the body is equal to the density of the fluid into displacement of volume of the fluid, that can be written as rho Vg. So, this is the experimental verification of the Archimedes principle and the two conclusions.